So, first of all, I would like to thank Farzad. He was kind enough to switch places with me in the Tech Week Center. Otherwise, I would be holding this presentation in about probably 5 months from now. Who knows? I am very lazy. But I'm very excited to be here, talk about this, something that I find interesting. Hopefully you also find interesting, and the people on the remote sites and the possible podcast listeners also. So, most of you might not even know me. Some of you might know me as that designer guy who only wears Adidas, or the guy who sings karaoke in all the company parties. Actually, I'm neither one of those. I'm a software developer. My name is Niclas, and I've worked here in Futurice for now 2.5 years. And the last year, I've been working with Clojure, which is the topic of the talk today. Clojure, what is it, and why does it have so many parentheses? Before we begin, I'd like to clarify that I hope that everyone will walk away from this talk learning something new. My biggest fear is that after this talk, you will still be as unfamiliar with Clojure as before this talk. So, very excited to teach you something new. So, what is Clojure? That's a very good question. Clojure is a programming language, but what kind of programming language? Clojure is actually a Lisp family language. What is Lisp? Lisp is actually the second most oldest programming language in the world, only beaten by Fortran. It was designed in the 1950s by a computer scientist named James McCarthy. Clojure, on the other hand, is developed and overseen by its benevolent dictator for life. This is the actual title, Rich Hickey. And like Lisp, Clojure is also a general purpose programming language, meaning that you can create anything from web apps to microwave ovens, if you feel like it. I hope you don't do it. Also, Clojure is compiled, meaning that the Clojure code you write actually gets transformed into something else, in most cases Java bytecode, since Clojure runs on the JVM, Java Virtual Machine. Also, like Lisp, Clojure is dynamic. Now, dynamic is something familiar to all of you. Dynamic programming languages like JavaScript and Python and Ruby, where types are only known at runtime and not at compile time. Also, Clojure is strongly typed, unlike, for example, C or JavaScript, where the type can be forced to being something else. In Clojure, a string is always a string. It can't be converted into a number. There are, of course, exceptions to this. Clojure will coerce doubles into ints, for example, in some occasions. Clojure is also a functional language. Now, this talk is not about functional programming at all, but functional is just a programming paradigm like object-oriented, procedural, etc. The most interesting thing about functional programming, it's based on mathematics for the most part, and mathematical functions. Same input given the same gives the same output without any side effects like exceptions and etc. And immutability is heavily encouraged, meaning that data cannot be mutated into something else. But that was quite a mouthful, actually. But this is mostly just technical jargon that this talk is not about, but it's good to know some basics about the language before you just jump headfirst into the syntax without knowing anything. But the rest of the talk won't include any of this technical jargon, only code examples. And the first example we'll look at is a comment. The comments in Clojure start with the semicolon. And you can have as many semicolons as you like. There's no limit to them. The amount of semicolon usually indicates emphasis that this comment is more relevant than the other comment. There are no block comments though, so if you want to block out a whole section of code, you have to write a semicolon on each line. But the next thing we'll look at are types. Since Clojure runs on the JVM, the types in Clojure are really actually just Java classes. A string is a Java string, a double is a Java double, and an int is a Java int. And nil represents the null value, the lack of a value in this case. But then, yeah, and also interesting, you can check, of course, as the comment says there, you can check the type of any Clojure type with the class function. More on these functions later on. In Clojure, we also have lists and vectors. There are slight differences between the two. Lists are actually under the hood linked lists, and vectors are array-backed. The differences are just that in linked lists, the elements are connected by pointers, and the vectors have their elements adjacent to each other in memory, meaning that you can read a vector faster than you can read a list. But you can choose whichever one you want. There's not that big of a difference. These are also just under the hood Java classes. We also have maps. As is everything else, it's also a Java class. There are two different kinds of maps though. There's an array map and a hash map. Array maps, the biggest difference between these array maps and a hash map, if your map is bigger than 10 keys, Clojure will automatically turn it into a hash map instead of an array map. What is the difference between the two, you might wonder? Array map, the keys are ordered, so meaning that the way you structure the map, depending on how the order you put the keys, they will always be in that order, while in a hash map, they might be in a random order. Usually the keys, this is kind of annoying, this mic. Usually the keys should be a keyword. A keyword is a Clojure type, the class also, as you see here, excuse me. But keys can also be strings. But we'll delve into this more later. But something also the Clojure has are sets. Now, sets are basically just lists, but the list can only contain unique values. You can't have duplicates in a list, in a set, that is. Sets use this syntax, the pound sign and the curly braces. It makes a set. But now, basic hello world function, hello world program in Clojure. Excuse me, this mic is kind of awkward. So here we see what a function looks like. So in Clojure, the compiler always expects the first thing it sees inside the parentheses to either be a macro or a function. Now we won't talk about macros right now, but in this case it's a function, and the function would be print line. And everything that comes after the function or the macro is perceived as arguments. In this case, hello world, either 3 strings, 2 strings, or 1 string. They all produce the same output. Then math. Math is pretty straightforward in Clojure. Again, everything is a function. The plus, which is normally an operator in most languages, or minus, or any of the mathematical operations, they're actually functions. Interesting thing about these functions, they all take an amount of arguments from 0 to n, meaning you can have an infinite amount of arguments passed to these functions. The only exception is the minus function. It requires at least 1 argument. I don't know why that is. Logical functions, also seen as operators in other languages. In Clojure, there are functions. These functions, just like the math functions, also take from 0 to n amount of arguments. The interesting case you can see here is the greater than function. So this function, if you give it more than 2 arguments, it will always check if the first argument is greater than the second one. If, in this case, it will check is 5 greater than 4, is 4 greater than 3, is 3 greater than 2, and so on. If all the cases are evaluated to true, the function would return true. Of course, there are exceptions also that one of these functions, I don't remember, does not take 0 amount of arguments. There are more logical functions. Since the function standard library for Clojure is pretty huge, it's expected to see a lot of them. Again, unlike in most programming languages where these operators are usually indicated by ampersands or exclamation marks or double pipes. In Clojure, they're just plain functions, and arguably more readable since they're represented in plain English. These functions also, except for the not equals, take 0 to n amount of arguments. Ifs, also, like everything else so far, is a function. Actually, it's a macro, but more on that later. It's seen as a function that can take 3 arguments, the third one being optional. So, an if would take as the first argument the Boolean, and the second argument would be the truth value, and the last one would be the false value. Some people say that if you omit the else clause, you should use the when function, since when will omit automatically the else clause. However, the when function evaluates everything that comes after the first argument, so in this case it will evaluate all the strings and return the last one always. So there might be some unexpected behaviors in this case. So loogie would be returned here. Predicate functions. Now, predicate functions are quite easy to understand, in my opinion. They always return a Boolean, and they are always appended by a question mark. You will always understand that this function returns a Boolean. It's a dynamic language, so you won't know ahead of time what it will return. But with this syntax, you might easily understand that this returns a Boolean. Now, this is only a minor fraction of all the predicate functions available in Clojure. So like I mentioned, the standard library is rather huge. Now you might be wondering that this is all nice and fancy, but where's the good stuff? Where are the variables? Where are the functions? Hold on. They're actually next. With def, you can create variables. Def is actually also what you call a macro or a function. So it only binds one value to a name. And with defs, you don't need parentheses to evaluate what's inside it. It's already evaluated. It's just a reference to the name, the value. And some of you are probably more attentive than others, and you realize that my last parenthesis is a bit more transparent than the first one. This is just because I use this plugin that automatically adds parentheses for me, so I don't have to worry about it. And functions. There are many ways you can create functions in Clojure. The first one here in the example is an anonymous function, and if you just write it like that, Clojure will just return a function, but it has no name. It doesn't really exist. So how would you call it? Well, you would have to add an extra set of parentheses to call it. You can also put functions in defs, so you can give them names. They're not anonymous anymore. However, the def syntax is rather verbose. There's a preferred way to write it with def and shorthand version. This is the preferred and common way to write functions in Clojure. One thing about functions also is, remember, functions will always return its last statement in Clojure. You might be wondering, what is actually that bracket after the function name? It's actually the argument list. Anything inside that list will be available in the function block, so inside the function's parentheses. In this case, you can write hello and pass the hello function a name, which is Steve, and produce hello Steve. Function can also be multivariatic or function overloaded, whichever term you prefer. It means that a function can take a different set of arguments and produce different operations, depending on how many arguments you pass to it. So in this case, we can have a function that takes either 0, 1, or 2 arguments and produce something like that. Functions can also have an optional docstring. A docstring would mean just you can inspect what a function might do with the docstring. However, docstrings have to be written by hand, and they are prone to human errors. So with the doc function, you can check what the docstring is. However, the docstring might lie, and you may get unexpected results. It's better to always check what the source of the function looks like. With the source function, you actually get the whole source code of the function with that source function call. Now, function with the ampersand sign, you can also get an infinite amount of arguments. Now, this is what I mean when the math functions take an infinite amount. With the ampersand sign, everything that precedes it will be just packed into a lazy list. More on that later. But you can interchange between the two. You can have a named function and a lazy sequence. Functions can also have nullable arguments. Nullable meaning that it may or may not exist. Everything that is inside after the ampersand inside the brackets will be seen as nullable. Now a little bit of trivia here. What do you guys think the last function call returns? Anyone want to take a wild guess? It actually returns the same thing as the second one. Hello, John. Since everything is packed into a list, Clojure will only actually use the first element in that list after the ampersand in this case. And the let block is actually just a way to bind a value to a name. You might think of it as a variable. Sorry, this headset is rather awkward on me. One thing to remember with these let blocks is that the variables, as we would call them, don't exist outside the scope of the let block. So if you try to call them, you'll get a runtime exception. Let blocks go hand in hand with functions. So you can have let blocks inside a function and have local variables, so to say, in these functions. In this case, we'll pass a string and take the first character from that string and store it in a local value. These values will not exist outside of the function. Now we get to maps. As I mentioned before, maps are key values. You can have either a keyword, a Clojure keyword. A Clojure keyword is recognized with the colon. So everything, if you have a colon and some text, it will be evaluated as a keyword. So maps usually have keywords as keys, although you can have strings also. But the preferred way is to have a keyword. How do you actually read a map then? You would just put the keyword. You could either use first get function, or you could just use the shorthand, which is the get shorthand. You just put the keyword and then the map. You would then read the value of that key. Although you can also interchange. You could either have the keyword as the last thing and the map as the first. Although there might be unexpected things if you have strings as keys. In this case, if Baz was a key, or if you would write it as this in this case, this way, Baz would be interpreted as a function, and strings are not functions in Clojure, so you'll get a runtime exception from this. If you have a nested map, you want to get deeply into a value inside that, you would use the get in function. These are the most common functions for maps. So, and one thing to remember, maps are immutable in Clojure. So all of these functions return a new map. You would have assoc, which would add keys and values into a map. And you would have dissoc, which would remove keys and values from a map. And you would have update, that would update a key value with a function, in this case inc, would increment the person's age. These are also just a fraction of all the functions available in Clojure for maps. Now, next, sequences. Now, what is a sequence? Well, sequence is basically just a list of data. All of these are all considered sequence or collection functions in Clojure. One thing to also consider, this is also just a minor fraction of what is available in Clojure. The standard library is really huge. All of these, except for reduce and take, will produce a lazy sequence. A lazy sequence meaning that the list can be infinitely huge, but the values have not been evaluated yet, and the evaluation is called realization. So they exist, but the value is only known when you access the list. If you give range 0 arguments, it will produce an infinitely long list from 0 to infinity. But still, the program doesn't crash. It's lazy, the list, and take 5 would take the 5th element from that list and return it. Next, we get to my favorite feature of Clojure, macros. Specifically, the threading macro. Macros might be familiar to you if you've ever done C or C++. Think of macros as these functions on steroids. These macros give you the opportunity to extend the programming language. You can basically create new syntax. The most used macros in Clojure are the threading macros. These are very, very nice. In this situation, we would thread the first argument, in this case is a map, and it would be passed as the second argument to each function in the function chain. This map will get passed to ASOC before the C, although you don't see it here. And then the result of the ASOC function would get passed to this soc, would then produce this new map without the D key. Now this might be, for you, you might think that, well, actually I prefer to have the argument as the last argument also. Well, don't worry, Clojure has a macro for that also. It's called a double arrow macro. So in this case, the argument will always get passed as the last argument in the function chain. You might also, this might be actually familiar to some of you who've used any sort of OCaml type language like Elm or F# or OCaml itself. This sort of feature exists there also. But you might think also that this is all nice and dandy, but I want to pass the argument like in the middle, in the last, in the first. Like how the Clojure doesn't solve that. Actually, it does. There's a macro for that also. You can give your argument a name, in this case input, and pass along wherever you want in the function chain, as the first argument, as the last one, wherever. You just have to reference the name of what you gave it. But the most common macro is actually the namespace macro. All Clojure functions starts with a namespace. Namespaces are just a container for your code. You can require different namespaces and give them names inside the ns macro, so to say. Put everything together. This is a regular Clojure file. It will look something like this. So, everything we've gone through now, we have a namespace, my Clojure project. We require the Clojure string namespace. There are two things that we haven't gone through yet. In the underage function, there's a dash after the defn. It just means that this function is only available inside this namespace. It's a private function. Also, the def, the variable default person we have here, is also only available inside the current namespace. But everything else is something we've gone through. We have a multivariatic function that takes either 0 or 2 arguments. We have a many new persons function that takes 2 equally sized lists and maps over them in parallel and creates new persons. We have a predicate function that checks if the person is underage. And then last, we have an underage persons function that filters underage people and takes their names and capitalizes them and produces a list of capitalized names. These functions might be useless. It's just an example what you can write. But you might be still thinking, like, even after all this, why are there so many goddamn parentheses? Like, I can't wrap my hand around it. Well, interestingly enough, there aren't actually that many. Here we have 2 functions do exactly the same thing. One written in JavaScript and one written in Clojure. So we just concatenate a value to a list, filter out odds, and reduce them down to a number. Each one has the same amount of parentheses. It's just that in Clojure, the parentheses go on the other side, on the left side of the function name. It looks unfamiliar to the human eye, and something most humans are resistant to something that is unfamiliar. So that might be the reason why people see that Clojure is something that is very confusing. But before I end this presentation, I'd like to just mention that we do have a fair amount of Clojure experts in this company. One of them is sitting right here. The one, Carita, is sitting right there. We have a Clojure flow. If there's anything Clojure related that you want to ask, please join that flow and ask whatever you want. Mostly it's just me asking stupid questions about Clojure because I just feel like it's something I need to learn. And the other thing I want to say that Futurice is helping in organizing Clojure Bridge. Clojure Bridge is an event designed to help to teach women or anyone who identifies as one to code in Clojure. I will be there not as a woman or anyone who identifies as one. I will be there as a tutor. If you know anyone or would like to be a tutor yourself, please feel free to sign up or ask me or Uka for advice. There's not much to it anymore. I hope that this something that is unfamiliar now, Clojure, is more familiar to you now than it was before. If not, please, feedback is appreciated. What could be done to make this more clear? Thank you.
Thank you. There's questions coming up.
But my question is, since the standard library, as you mentioned, is pretty huge and covers most of the use cases, how hard is it to get productive with the standard library and to know that you're using the best reasonable way to do stuff in Clojure?
This is a very good question. So this was something I found difficult myself. There is a website, Clojure Docs, has every function and descriptions on the functions. So I would recommend just going there and looking, like, is the function I'm using the most reasonable one? Can you find something else? The one thing I've learned in Clojure, you would write a complicated reduce, and a week later you would realize, oh, there was actually a function in the standard library that does this exact same thing. It's a never-ending learning experience since the standard library is pretty huge. But Clojure Docs, that is the place to check out.
There's also a site called Clojure Cheat Sheet, which is a nice link, list of links to the most used functions. And another one for Clojure script, so Clojure script being the variant that is compiled into JavaScript as well. And yeah, in the REPL, you can also use the doc function that would fetch the documentation from Clojure Docs for each standard library function, which is also pretty nice to use.
Even the doc.
Yeah, doc, maybe, I'm not sure, maybe doc is a macro.
Doc
probably.
is a macro also.
Yeah.
Thanks for your talk. It was really interesting. And I don't know too much about Clojure myself, but I've spent some time in the Java world, and I'm kind of curious. You mentioned that it's using Java under the hood for primitives and this type of thing, simple classes. What types of things, like what happens with side effects? Are you ending up having to go back to Java land with like really long variable names, or how is that handled? And is there, like what is that kind of delineation, if any?
So the question was if you have to interact with Java. You are not at all forced to interact with Java, so to say, since most of the Clojure everything is written in Java, so you interact in that way. But you're never forced to call any Java functions, so to say. Clojure has their own standard library that handles most of the things. Of course, you can, of course, just call like the date, for example. It will be a Java date, so you can interact in that way, and you are free also to choose any Java library and import them in your Clojure code, and it will just work. And that way you can also interact. But being forced, I wouldn't say you are ever forced to interact with Java, ever.
My question, Niclas, to you is, if you go back to this very big holy war between dynamic languages and like statically typed languages, so I mean, how do you see, like, how big of a difference for you it was to write stuff in Clojure than in JavaScript? Was it the same pain for you as in JavaScript to sort of realize what is broken by rerunning like your program again and again and again? And then how helpful are the exceptions you get from the Clojure?
This is a very good question. So, for me, in the beginning, it was just as painful because you end up doing the same mistakes ever. Sometimes you might get nil and you get these runtime exceptions. And since they are Java exceptions, the error messages don't necessarily tell you anything. You get these long stack traces and try to figure out from there what it is actually you're trying to do or trying to debug in this case. But later on, as I grew to understand Clojure more, it became a lot easier and not as painful, or what some might consider as painful, to write Clojure as it is to write JavaScript.
Are there any tools which help with this sort of, maybe not exactly type checking, but something similar which will, show you some issues in the IDE? Like,
Yeah.
for example, in ESLint, you would at least see which, like when you made a typo, something like that.
Yeah. So there are actually two ones. One is called Schema, and the other one is called, forgive me for not remembering what it was called, but these are sort of type checkers. So you can use these, and they will produce more helpful error messages at runtime at least, and they will also tell the programmer what is expected in this type at least. So if it's a string or if it's a complicated map, it will tell that this complicated map should at least include these keys. And yeah, as I said, it will produce more helpful error messages. So, but I still haven't had time to try them out myself. I will at some point.
I wanted to comment to James's question that basically it's pretty straightforward to interact with Java things, and often many libraries that you use are wrappers around the Java ones. So for example, there is a complete Java SDK for AWS, and you have a Clojure wrapper where you can just call all the stuff via Clojure native functions, but underneath it will use the Java thing, which is of course, it gives you access to far more greater space of libraries. So in a way, I would see it as a richness of the platform. And what comes to the side effects, you won't use Java to do side effects. If you want to have state, you would use atoms. Atoms is the kind of Clojure native way of storing state. Yeah.
So one quick comment to that also, since I mentioned about the syntax in the predicate functions. So if a function is appended with an exclamation mark, it means that this function will produce a side effect, a mutation of some sort. So, but they're usually, as you can mention about the atoms, they're usually only used for atoms. So a programmer would then know that, okay, this function takes an atom, and it will produce some sort of side effect in this case.
Isn't print line a side effect?
That's a very interesting question, actually. A print line, well, there's... I like this question. So, also exceptions are thrown in Clojure. They are also considered side effects. But in this case, I think print and print line, since they will always return nil, so they won't be considered in Clojure as something that produces side effects. But that's an interesting point you bring up there. So,
but it's true, Ossi.
Yeah.
It's a side effect. Yes. So in effect, the function names with exclamation mark or question mark, they are just convention. You don't have to put them there. So for some reason, maybe we should ask Rich why doesn't println has exclamation mark.
But there are long discussions about this. There are long discussions about what is the proper way for Clojure to, like the syntax convention, and what is a side effect and what is not. And yeah, but very, very good question, an interesting one.
I'm so sorry for asking too many questions, but
no problem.
Would it be wise for someone to get up and running with Clojure as the first programming language which is completely functional?
Would it be wise? So you're asking if my opinion, if it wise. In my opinion, Clojure is relatively, since it's a Lisp language, it's relatively unfamiliar to all the different C-style languages. In my opinion, it would probably make more sense for someone to start off with something different, that's more familiar, so it's easier to someone's skill set than in the future to learn some other languages, than to start off with something that seems so unfamiliar to the C-style languages. This is just my opinion, but of course, whatever you choose, feel free to choose. I am not going to force anyone to use anything ever.
Of course, starting with a functional language would be a good thing. Then you would not be spoiled with the wrong ideas when you learn the right things first, right? I'm provoking a bit, yes. Any other questions? By the way, there was comments in Flowdoc for awesome presentation, mega entertained over here. So Olavi and Fotis sending greetings from Oslo. Thank you,
Can you hear us?
Niclas. I guess that was it, right?
That was it. Yes. Thank you.